Modern web frameworks allows us to describe our UI declaratively as a function of a state of the application. The function can be written in a form of templates or template-like syntax, which describes exactly how the view should look like in all possible states. When the state changes, the view should change as well. We don't need to describe how the view transitions from one to another. We don't need to describe how elements are added, removed, or modified. Modern web frameworks do that for us. The framework magic takes in two subsequent views and figures out how to transition from one to another. Modern web frameworks like React and Vue do that using a technique called Virtual DOM. To handle all possible scenarios, this framework magic could be very huge in code size, and it is independent of the application it is supporting. For React, it's 40 kilobyte gzipped. Vue 2 is 23 kilobytes, Vue 3 is 10. And if your application is simple, it could disproportionately small in terms of code size relative to the framework library, which is shown in the gray portion of the chart. However, this doesn't have to be the only way of doing things. What if we could shift all the work done in the framework magic from runtime to build time? We can analyze the code and figure out all the possible states and views and the possible transitions between them and generate just enough code to do just that. And that's the core idea of Svelte. The Svelte compiles the Svelte code into optimized JavaScript code that grows linearly along with your application. And today, we are going to look into the Svelte compiler. Don't worry if you're not familiar with Svelte or compiler. I'll try my best to avoid the jargons and explain the general idea of the process. My name is Tan Lee Hao. I'm a software engineer at Shopee. Shopee is an e-commerce platform in Southeast Asia that is based in Singapore. I grew up in a lovely town called Penang in Malaysia, which has the best street food in Malaysia, such as char kway teow, stir-fried flat rice noodle, rojak, eclectic fruit salad with palm sugar, peanuts, and chili dressing. Just don't get me started with food. So hopefully you guys can come visit Malaysia after this coronavirus pandemic is over. Last but not the least, I'm one of the maintainers of Svelte. Before we start talking about compilers, for the benefit of those who haven't had a chance to take a look into Svelte, let's take a look at how Svelte component looks like. A Svelte component is written in a file with a .svelte extension. Each file describes one Svelte component. You can add a script tag to the component. The script tag allows you to define a variable just like how you would in any JavaScript code. And you can add a reference to the variables into HTML tags with curly brackets. To add event listener, you use an on directive, and you can update a variable just like this. It will automatically update it in your DOM. You can add style tag and write some CSS to style your component. What's cool about it is that the CSS is scoped within the component. So when I say button, background red, not only the button is written in this component file has the background red, not the child component, not the parent component, just this component. Now here is one of the most powerful and somewhat controversial feature of Svelte, reactive declarations. Here you have double equals to counts times 2 with a dollar and a colon sign in front of the statement. This means that the variable double is always 2 times of count. Whenever the value of count has changed, the value of double will update as well. This definitely feels weird in the beginning, but the more you use it, you ask yourself why we didn't have this earlier. So here we have one big red button and a text of multiply equations as Svelte component. I'm going to pause here for a moment and ask you this question. How would you implement this if you're not allowed to use any framework and you have to write it in vanilla JavaScript? So firstly, we are going to start with the variable declaration. Next, we create the text with document create text node and insert it to the parent. We can create a button using document.create element, set the text, add event listeners, with add event listener and append it to the parent. To update the text, when the count is updated, we can create an update function where we update the value of double and update the content of the text. And finally, for the style tag, we can create style tag with document.create element, set the text content, and then append it to the document head. To make sure the button only targets this button that we just created, we add a class to the button. Here the class name is random, but it could be generated based on the hash of the style code, so you can get consistent class name. In fact, if you take a look at the Svelte generated JS output, it looks very similar to the code we just wrote. So this is just the code you need to write to create a button and a text. You don't need 40 kilobyte Virtual DOM library to recreate the same component. Of course, you don't have to write all of this yourself. The Svelte compiler will do it for you. It will analyze the code and generate the code like this one. And now if you try to choose SSR, which stands for server-side rendering, as the generated output, you can see that Svelte generates a function that returns a string composed using template literals. This is a few orders more performant than generating a tree object and serializing them into HTML string. So let's take a few more examples of Svelte syntax, and along the way I hope you ask yourself this one question: how do I convert this and write this in plain JavaScript? And don't worry, you can find this REPL on the Svelte website, and you can compare the input and JS output any way you want. So to express logics with template, Svelte provides logic blocks such as if, await, and each. To reduce the boilerplate code for binding a variable to an input, Svelte provides the bind directive. To provide transitions for element coming into or out of the DOM, Svelte provides a transition in, out directive. And to compose components, Svelte provides slots and templates similar to the web component APIs. There's so much more I would like to share here, but I have to segue into the Svelte compiler because that's the main topic of today's talk. So finally, let's take a look at the Svelte compiler. Before that, how does a compiler works? A compiler first reads through your code and break it down into smaller pieces called tokens. And then the compiler goes through this list of tokens and arrange them into a tree structure according to the grammar of the language. The tree structure is what a compiler calls abstract syntax tree, or AST for short. And AST is a tree representation of the input code. And what the compiler sometimes do is to analyze, apply transformation to the AST using tree traversal algorithms such as depth search. And finally, the compiler generates a code output based on the final AST. In summary, a generic compilation process involves passing the code to an AST, doing analysis, optimization, or transformation on the AST, and then generate code out from the AST. Finally, let's take a look how Svelte compiler works. Svelte passes the Svelte code into AST. Svelte then analyzes the AST, and which we will explore in detail later. With the analysis, Svelte generates JavaScript code depending on the compile target, whether it's for server-side rendering, SSR, or it's for the browser. And finally, JS and CSS is generated and can be written into file or be consumed by your build process. So let's start from the beginning, the parsing. Here is a Svelte component that we are going to use throughout this talk. So we have variables, each block, input, binding, right? So Svelte implements its own parser that parses HTML syntax as well as logic blocks such as if, each, or await. Because JavaScript is a fairly complex language, whenever Svelte encounters a script tag or a curly brackets, it will hand it over to Acon, a lightweight JavaScript parser, to parse the JS content. The same thing goes with CSS as well. Svelte uses CSS tree to pass CSS content in between the style tag. So through the process, Svelte code is broken down into tokens and is arranged into Svelte Ast. And if you're interested to see how Svelte Ast looks like, you can check them out at astexplorer.net. The next step is to analyze the AST. Here our code is already in AST, but to help visualize the process, I'm going to show you the original code. The first thing Svelte do is to traverse through the script AST. Whenever it encounters a variable, in this case count, it will record it down to the variable name. Here we record values and double. The double here in this Svelte code is a reactive declared variable, but the vanilla JavaScript, we are assigning values to this variable double which is not declared anywhere. In strict mode, this is assignment to undeclared variable error. Svelte marks this variable double as injected, so the declaration of the variable will be injected later. Other examples of injected variables are Svelte magic global, such as $props or $prefix of a store variable. Here we encounter count again. This time it's being referenced instead of being assigned to a value, and it is used to compute the value of double. So we draw a dependency relationship between count and double. So double is depending on count. Let's continue. Here we see data. Data is not declared at the top level scope, and as it is within the curly brackets block scope, so we are not going to record it down. Same thing goes with I. Here we encounter double again, so we mark it as reference. Math, a JS global, so we're going to ignore it. Here values is mutated. So we reach the end of the script. The next step is to traverse the template AST. We start from input element, which has a bind value. Here we are binding the value of the input to the variable count. So we mark the count as reference from template and mutated. Now we encounter that each block. Here we are iterating through the variable values, and we are using the variable value as each item. So the template within each block will have a new scope where values is declared. So we mark values as the dependency of the each block. This means that whenever values has changed, we are going to update the each block. And we mark values as reference too. Next, we move into the each block and the div element. Here we mark value as reference from a template. Here we encounter value again, and we have reached the end of the template. Next, Svelte traverses through the script again, this time mainly for optimization, figuring out which variables are not referenced and does not need to be reactive. Similarly, if a reactive declaration dependencies will never change, by seeing whether their dependencies were marked as mutated, we can mark it as static, which will generate a more efficient and much smaller code later on. Next, Svelte traverses through the style. So for each selector, it will determine whether it will match any elements in the template. And if it does, Svelte will add a Svelte hash class name to the selector, as well as the match elements. Although this will increase the specificity of the selector, but it will make the selector scoped only to the current Svelte component. At the end of this step, Svelte has figured out all the variables declared and the behavior and their relationship. With this, we move on to the rendering phase. This step is where Svelte will generate the JavaScript code. There are two different compile targets. One is for the DOM, for the client side, and another is SSR for the server side. Let's first take a look at the DOM render target. Here we have the source code, and here is the outline of the DOM output looks like. So firstly is what I call a fragment block. The create fragment function returns an object that acts as a recipe to create the elements in the component. Each method in the recipe object represents the stage in a component lifecycle. So here we have the C for create, M for mounting, P for update, and D for destroy. Next one, we have an instance function. Here's where the state and component logics goes into. Finally, we have the Svelte component class. So each Svelte component is compiled into a class, which is the default export. In the constructor, as you can see, calls the init function, which takes in the instance and create fragment function. This is how the three different pieces of the Svelte component come together. Now, Svelte walks through the template again and starts to insert code into the output. First, we have the input element. We insert instructions to create the input element, mounting the element to the target, and remove the element. Next, we have the binding of input value to the count variable. We need an input handler to listen to the input changes so we can update the value of the count variable. So here we pull out the variable list and we add the input handler variable in. We set the input value based on the variable count and add events listener for the input changes, which we should remove event listener when we destroy the component. And in the update phase, if the count has changed and we need to update the value of the input based on the value of the count. Next, we move on to the each block. We create a new fragment block for each block, which contains the recipe for creating elements for one each item. Because in each block, we can have a child scope that defines a variable value. So we create the getEach context function to emulate that. Here we fast forward through the steps where for each element we insert code for how we create, mount, update, and destroy them. If you're interested to know the details, you can check out my series of blog called Compile Svelte in Your Head. Now we'll look at how Svelte fills up the instance function. In most cases, Svelte just copies over whatever is written in the script tag. However, for reactive declarations, they were added inside the $update function. And for each statement, we add an if statement to check whether their dependency has changed based on the dependency relationship that we have drawn earlier. Now we need to declare and add those injected variables. And finally, we return a list of variables that are referenced by the template only. That is count, values, and input handler in this case. Now to make the variables actually reactive, we instrument the $invalidate after each assignment statement so that it will kickstart the next round of update cycle. So here you have it, the compile output for the DOM target. Let's take a quick look at how things going for compiling for the server-side rendering target. The structure of the output for the server-side rendering target is much simpler. It is a function that returns a string. Because there won't be any reactivity needed in the server, you can copy over the code verbatim from the script tag. Same thing goes with reactive declarations. Of course, we need to remember to declare the injected variable double. As we traverse through the template, we add insert strings or expressions into the output template literal. For the each block, we iterate through the variable values and return the child elements as string. And there you go, the output of a Svelte component for server-side rendering. So finally, Svelte outputs the code in JavaScript and CSS with the code as string as well as a source map. This can be written into the file system directly or be consumed by a module bundler such as Rollup Svelte plugin for Rollup or Svelte loader for Webpack. So let's review again the Svelte compilation process. Svelte passes the code into AST, run a series of steps to analyze the code, tracks the variables, references, and dependencies. And then Svelte generates the code depending on the compile target, whether it's for the client side or for the server side. And the output of render step is in terms of JavaScript and CSS, which can be written into file or consumed by our build tools. And that's all. Thank you so much for listening. If you'd like to learn more about Svelte, or if you have any questions about Svelte, you can follow me on Twitter at @lihaotan. Lastly, I hope you have fun with the talks throughout the conference. See you. Yeah, great.
Nice to meet you. I'm Adam. I think what I'm supposed to do now is gather any QA questions, but thank you very much for your presentation. Amazing to see the inner workings of Svelte and more about ASTs. My head always explodes when I see that stuff.
Thank you.
So I think at this point we should be welcoming Q&A. Tony, I don't know if you're in on this chat.
I am here, but my camera's not working for some reason. So hopefully we'll fix that for the next one. Tan, that was an amazing talk. It really explained what Svelte was to me. So am I right in saying Svelte is another framework for us to do awesome things with JavaScript, broadly speaking?
Yep, that's right. Okay.
And is there a reason that I would want to reach for Svelte over one of the other frameworks? You know, what's its amazing capabilities? What's its winning feature?
So if you ask about why do you think why should you choose Svelte instead of other frameworks or other libraries? I would say first thing is Svelte is a compiled framework, which means that basically you don't really get any of the Svelte code. Most of the Svelte code is not downloaded to the user, right? Most of it is being it's like a compiler where it tries to analyze your code and then generates a very small and efficient and optimized code that will be sent to the user. So basically, your code size will grow will scale linearly as how much you write in your code, right? I think that's a very big win compared to other frameworks. Right? For example, in other frameworks, you may have just like a hello world, but if you look at the browser, how much code is being downloaded, it may be like a few KBs, 100 KBs, or a few tens of KBs, right? But in Svelte, it will be just, because if you're just doing a hello world, then it will be just code that creates an element, a text node that has hello world on your browser, and that's it. So that's a main difference of Svelte, I would say.
Okay, that was very succinctly described. Thank you very much.
Here from Igor, he's saying, would a Svelte app have a code size advantage over Vue React apps for pretty big apps? So I mean, I suppose the question is there a size at which sort of the overhead of React and Vue and that model is an advantage over Svelte for optimization? I mean,
yeah, so I think we get this a lot, and I think recently, if you guys are following on Twitter, I think someone calculated like how big Svelte code will scale in proportion to your your application code, right? So that usually would be like, you can imagine your code size will, like the output code size that the user will get will increase linearly with like a certain gradient and a certain like y-intercept. So that would be like the base of, say, a framework, and then it grows linearly at a certain gradient, right? And maybe for React, it will start very high, and then maybe the gradient will be, the slope of itself, maybe it's a bit small. And so people were conjecting like whether they're like, where is the inflection point where two lines meet, and React will eventually getting a smaller code size compared to Svelte. Well,
I can't remember the numbers. I'm very bad at numbers, but that will come very, very late at if you have a very, very big applications, which in most cases it's you won't reach there because by the time you reach there, you would have say do optimization such as like code splitting and things like that, which will you may not need to load all the codes in your browser. You can just split based on route, and per routes usually maybe per page you don't really need. You won't reach that code size, right? That's what I say. I'll probably find a link.
Okay.
So there's like a study, there's a code samples on how they calculate this, and probably I'll drop the link in the chat and you guys can check that out.
Yeah, that would be brilliant. Thank you. There's another question that's come in here, which kind of leads out from that. Does Svelte do any Beybladifying in output?
Okay, so
or is it by default ES5?
Svelte actually, I wouldn't say even ES6. It's more of like the ES currents, right? So we don't process that. We would like transpile it down to ES5 or any version of JavaScript. We will just based on whatever is currently in ES, so which is 2020. So in fact, if you write something, say ES 2020, such as like optional chainings, we will just output as optional chains, right? We won't do anything. So if you want to support browsers that doesn't support it, then you have to pipe the output to a Babel to transpile to any targets that you're looking for.
What about source mapping? Just quick answer, because
okay.
We using source mapping from sort of compiled code in other libraries too. Does that fit into the same answer?
Okay, I'm not really sure I'm getting the answer, but whatever you write you will output a JavaScript code and a source map, right? And that will map into whatever maybe Babel you're using. So it will take in the source map and the JavaScript code, and then do another transpilation, and like source map will chain, and you can figure out the original code.
Yeah. Actually, don't know what
how are we doing for time, Adam?
Here. Maybe someone can answer in the internal chat just for us. Let's go on with the question while we have. Yeah,
but we'll keep on going then.
Do you think Svelte is a good platform for learning JavaScript?
Generally, I would think yes, definitely, because except the weird label statement like the $:, which is not very JavaScripty, but besides that, everything is JavaScript, right? So we don't support we don't support code that is not JavaScript. Like the only case we are using it is it's a syntax of JavaScript, right? The $:, but we use it for other purpose. But besides that, whatever you write is JavaScript, right? It's JavaScript, standard JavaScript. So it's different. Like if you compare to other frameworks, say I would say like React, you may be learning about JSX, which is not quite a JavaScript syntax. And I guess if you are new, you may not know like the difference between them, and you may confuse. But if you are just learning JavaScript and you just want to write JavaScript code, then yes, Svelte would be great. Yeah, great for it. And also, like
the REPL is a win for that, isn't it?
Sorry.
So the online REPL is a big win for that sort of learning, ease of coding.
Yes, I see a lot of people are like trying like. I think people are not setting up Svelte locally. I have like maybe a hunch about that, because like everyone is just trying out Svelte on a REPL, learning things, and then share it and ask questions through the REPL. Yeah. So on tangentially, like if you're learning HTML and CSS, Svelte will be very good for you as well, because you're just writing HTML and CSS, right? You're not writing some other syntaxes that transpile to that creates HTML, right? Because I was from React, and at some point I almost forget that class name attribute is not HTML, so that takes a while to learn about that.
Okay, here's another question. Always gets asked. Can you use TypeScript with authoring Svelte?
Yes, you can. You can. So of course, but you can't do it now on the Svelte repo because it's not configured. Yeah, I think we are working on that. But if you set it up, I think basically in your VS Code, I think it supports by default. So if you install like the extension that does the type checking things, right, it will just work, right? Yeah. Mhm.
It will just work. Those are dangerous words,
Right,
Tan.
interesting. So is that new? Because I understood that Svelte didn't initially support TypeScript.
Yes, it was just announced
3 release.
recently, I think a month ago.
Okay, brilliant. Nice for the TypeScript people.
Yeah.
There was another question. Can you talk about the server-side frameworks, Sapper, or anything about the sort of? I just noticed there's a question here about, are there server-side rendering frameworks specifically for Svelte? I know there is Sapper, or does it support others, or?
So if you're just going for like vanilla of like without any, so Sapper itself is like a Svelte application builder, if I'm not wrong. I can't remember the acronym of it, but basically Sapper is like an opinionated way of building Svelte in both the server side and hybrid it on the client side. And it comes with a lot of opinionated like routing options and things like that, prefetching and a lot of those things. But if you just want to go vanilla, like like Svelte, there's two compile targets, as I mentioned in the talk. That one is for the DOM, one is for SSR. So you can actually compile Svelte into in a SSR mode, like a target to SSR. Then it will compile into like a function, and that function itself you can just pass it into any like server frameworks, like say Express. You can just have a middleware or handler that takes in a request and then just call this function and return whatever is written as HTML string. You can just do that. Then you don't have to use Sapper. But if you want like the routing, prefetching and all those things, then you can go for Sapper. And of course, there's a lot. So Sapper is maintained by the Svelte team. But if you want to go for something else, I think there's other options out there. I can't really remember all of them, but I will definitely link that up in the chat.
Yeah, I think that'll be useful. Yeah. There are a few questions here comparing to other frameworks. I'm going to read all of them. Is Svelte similar to Vue? What are the main differences between the way Svelte compiles code compared to other frameworks, for example, Angular, React? I think you covered that in your talk. And by your experience, what is the bundle size difference between Svelte and other frameworks and libraries, which I think you answered earlier. But do you want to answer any of those specifically, or?
I think I'm not sure.
I think you've covered most of that already, haven't you?
Yeah. So let me. I'm not very familiar with other frameworks, to be honest. Like I'm not sure whether I may misrepresent them, like comparing Vue versus Svelte. I'm not really familiar with Vue, so I can't talk much about it.
What about state management then? Let's move on to Svelte. Let's talk about Svelte. Like how can you give a short answer on how state management works in Svelte and maybe how that affects compilation? Okay, so by default, I think for one Svelte component you have states, right? Like how you write them is to just declare a variable in a script tag, and then you can just use them like they are like states where you change them. It will update on your component, right? But beyond the component, because Svelte compiles component by component, right? So if you want to share things across components, then it depends on how the two components are in relations with each other, right? You can think that in terms of, I think, Vue or React or all other frameworks. If it's a parent and child, then probably you do something like a props that works in Svelte. If they are siblings, then probably you can maybe share, hoist the state up, or you can do
or Svelte provides something called a store. So store is like I would say like a standalone store where you can subscribe and the subscribe to state changes on the store itself. So both of the components can just subscribe to whatever is in the store, and whenever it's changed, it will update it to and you can change each other any way around you want. So that is out of the box from Svelte, but of course you can definitely do whatever you want. Like say you can use Redux, no one's stopping you doing that. You can use Xstate, like if you want state machines, you can use Xstates or any other state management frameworks, or maybe you like doing reactive, for example, RxJS. That's okay. That works well with Svelte as well. So I think that all of them. I mean, there's no, let's say, you can use any state management frameworks out there and I think they work well with Svelte, right?
That's a good answer, because I think that's I mean, I was aware of a bit of the internals of using Svelte, but I wasn't aware that actually it was a straightforward swap with Redux and you could use it, which makes sense. Now that you mentioned it,
because great. Redux is introduced with React, but it is a store itself that you doesn't really need to be using it with React. You can use it with any other things as well.
I think we need to wrap up questions now because the next talk's ready, but I think a big round of applause, virtual one for you, and great talk, and thanks very much. I think the talk is ready. I'm just, if someone in the internal chat can just give us a view, and I'll hand over to Tony. Tony, you do the emceeing.
It's just about to start. It is just about to start. Tan, I'd like to say a huge thank you for your talk. It really, really opened up what Svelte was to me. It was something I wasn't really familiar with, and I'm sure there's a lot of people in the audience exactly the same. If you've got a one-sentence answer for this question, does Shopee use Svelte?
Using React.
Or are you using something else? And with that, we leave this Q&A there. Oh, no. Dan, thank you very much.
Thank you for having me. Thank you.
We appreciate your talk.